Hey everyone, welcome back to another video. In this one, I'm going to show you how to make any aerodynamic surface in SolidWorks. So that's going to start with importing an airfoil. And so once the aerodynamics team comes up with what airfoil is going to be used for the specific aerodynamic surface, you can then import that into SolidWorks and create that surface. So as an example, let's do an SD7062 airfoil. So you can just Google that, and then the first option that comes up should be airfoiltools.com. And so once you go here, it will show you the airfoil, and here it shows the coordinates of the airfoil. Basically, these are just plotted above in the graph, and what we can do is right click on the source stat file, and we're going to click on it, then it'll give us all these numbers. So now we can go to just a folder, open an Excel worksheet. We'll name it the airfoil name, open that up, and here we'll copy everything over to Excel. So as you can see here, everything is in one column. So we have 1 and 0 in the same column, and SolidWorks would not appreciate that. And we also have this row up here, which SolidWorks will not accept. So we'll delete that. And then to separate these, you can select that column and go into data and click on text to columns and just hit fixed width and hit next or finish, and now as you can see the coordinates are separated. Another thing SolidWorks needs is Z coordinates. So for all of these airfoils, your Z coordinate will be 0, so you can just put a 0 in the third column, and that's that. So now that we have this Excel file with all the coordinates for the airfoil, we're going to have to split them up into the top half of the airfoil and the bottom half of the airfoil, because SolidWorks gets a little confused if you try to import the entire airfoil all at once. So what we're going to do is just create 2 more Excel sheets, one called top, one called bottom. So we'll go to the top one, and actually we'll go to all the coordinates and copy and paste all of the coordinates that have a y value that is positive. So we'll just copy and paste that into the top one, and then we'll take all of the coordinates below the y-axis, so all the negative y values. Oops. And copy and paste those into another Excel file. And sometimes it is helpful to just add 0, 0, 0 to the top line of that one, because otherwise the curves may not be completely finished once we import it to SolidWorks. So now the next step is to save all these files. And we're going to have to change them to a .text file. So save as .text for all of them. And then you need to make sure you close all of these as well, because SolidWorks doesn't like it when they're open for some reason. So now that those are all saved, we can go into SolidWorks. I've already made a new part, and instead of starting a sketch like usual, we're actually going to go to Insert, and then curve through XYZ points. So we're going to go to our folder, and it only accepts .text files, so we can open that, and there you can see the start of our airfoil. So that's the top half. We're going to go back, insert another curve. This time, insert the bottom half. And now that looks like an airfoil. So to actually make a part, however, we're going to make a sketch, make it in the front plane, and we're going to convert these entities to a sketch. So now we have a sketch of the airfoil. And as you can see, there's this discontinuity here. So it's really small, so it doesn't really matter what shape you make it. So we're just going to draw a line there. And so some airfoils will have that in the front like this one did. Most of them have some discontinuity in the back where these two curves never meet. So either way, you can just draw a line between them and it's not a big deal. So that's our airfoil. However, it has a chord of 1 inch right now since we imported it as a scale of 1. So what we can do is just hit delete on these relations because we do not want it to be coincident with these curves we imported. And now we're able to just hit Smart Dimension on these points, and that will be through the curve or through the chord. And so we can make this whatever dimension we want. So let's say we want a 1 foot chord. We can just hit that, and now it's a 1 foot chord. And if we want to fully define this sketch, we can select a few things and get this part fully defined. Looks like this point needs to be coincident with the origin. And I think it's upset about this line we just added, so you can just add a dimension there and just hit enter on whatever value that is. Yeah, okay, it's still upset about that. So we can just add a relation again, make that vertical. You might have to play around to get this fully defined. It might just depend on the airfoil. So now we have a fully defined shape. So we can exit that sketch. Now what we want to do is create a 3D wing or vertical stabilizer or horizontal stabilizer. So what we're going to do is create reference geometry. In this case it's plane, and we're going to want it to be referenced from the front plane, but we want to add a distance. So this is whatever the span is of that surface. So if you have a 2 foot wing, you'd put 24 inches here. So we can just go with that, 24 inches. So now you can see this new plane is 24 inches away. And now what we're going to do is make a sketch in this plane. And we're going to do almost the same thing as we did last time. We're going to convert entities, but this time let's do this sketch that we just made. So once again, delete these references or relations, and we're going to add our dimension. So let's say that the airfoil or the wing is tapered, and so this first one we made, let's call that the root, and this new one we're making, we can say this is the tip. So if the wing has a tip chord of 6 inches, you'd put 6 inches here, and it's a much smaller airfoil. So now what we're able to do is get this fully defined. And so one thing we want to do is let's just scoot this over here for now. Once again, just try to get this sketch fully defined. We'll make that horizontal. We'll make this line vertical. Looks like I have the plane selected. And we probably need to add a distance here again. And it can just be whatever value it first comes up with. And we're also going to want this first point to be horizontal with the origin. So let's see what we're able to select here. We can select that first sketch, and that works. So now it just doesn't know where it is horizontally. So now this dimension depends on your taper. So right now I'm going to make a wing that has only taper where the angle is on the leading edge, and so the trailing edge will be completely straight. So in that case, it's just the root chord minus the tip chord, which in this case is 6 inches. So now our sketch is fully defined, and we can exit the sketch, and as you can see, we have an airfoil at the root and an airfoil at the tip, and we can go ahead and hide our reference geometry and original curve. So you can start to imagine the wing here. And then all that's left is to create a lofted base between these two. So all you need to do is select that sketch and that sketch, and sometimes it might take a couple tries to get that perfect, but eventually it'll come up with it. So now that looks like a wing, and we can say that that looks good, and that looks like a wing to me. So at this point, where you go in the CAD might kind of change depending on what you're working on, but say for a wing, you'll have to create a hole for the spar and holes for stringers, and on any surface you'll either have an aileron and flap on the wing, or if you're doing some stabilizers you'll have a rudder or an elevator. So it just depends what happens next, but that's how to create a pretty basic aerodynamic surface in SolidWorks.